All right, welcome back. So this is our last video for this weekend, and I want to talk about matrix multiplication, but I want to do it, I want to just show you kind of computationally what's going on. And then Monday in class, we're going to go a little bit more in depth. So we've got some questions. If you were in the previous video, we have some products that we haven't yet solved. So this question is saying we have A times C, C times D, C times B, and E times B. And we're going to see that sometimes these products are not even defined. And so that's what we're going to learn today. And so we'll come back to that in a second. But for now, I want to just talk about some notation that we might use in this course. And now is a good time to talk about it. Is if we have a matrix, and this is a big matrix A, we can talk about the entries. And so every matrix, if it's kind of general like this, will always have m rows and n columns. Okay? Usually our matrices are m by n. And sometimes we might want to talk about a certain entry. And so if we want to talk about one of those entries, we have to give the row of that entry and the column of that entry. And so for instance, if I say row I and column j, I'm going to write that entry by A sub ij. So the first number, in other words, the I is coming from the row, and the second number, the j, is coming from the column. So let's do an example. So imagine I wanted to find A34 of this matrix. Well, I've said that it's 8. Well, let's see why that's true. So A34, well, the first number is 3, so that means go to row 3, and go to column 4. So if I go to row 3 and column 4, I'm going to get that number 8. Right? And now similarly, we could check down here A54. Right? The numbers don't need to be one. The first number could be bigger, could be smaller. This is going to say go to the 5th row, go to the 4th column, and that's going to be there. Right? And maybe just one more example. If I wanted to do something like A41, that's going to be 4th row, first entry, that's going to be 0. Okay, so maybe do that down there. So we may need to refer to these sort of coordinates when we're talking about matrices. And so let me just cut to the chase and say what we're going to do. So typically, we are going to be given two matrices. So we're given two matrices, A and B, and they might be different sizes. And we want to know if A times B is defined and what it is. So there is a beautiful reason for what I'm about to do, and that's what we're going to learn in class on Monday. And I really wanted that to be more interactive, and so I want to show you computationally how we can think about this product. And I think this is actually going to be helpful to see this before our class on Monday. And so let me tell you first the rule for when the product is defined. Right? And so if A is an m by n matrix and B is a, let's say, I don't know, R by S matrix, right? These are just numbers, right? It might be a 4 by 5 by a 5 by 7, might be a 4 times 1 times a 3 times 6, right? There are all these different possibilities for the sizes of these matrices. So it's going to be defined only if n is equal to r. So in other words, these middle two numbers are the same, right? And so I'll even say that down there. So this is the way I like to remember it. The middle numbers need to be equal. And so let's just check that and see what's going on. Well, here's an example where we have the middle numbers equal. So I guess according to what Adam just said, that the product should be defined, but he hasn't told us yet how to do it. That's okay. He's probably going to tell us later. This product would not be defined. And I guess if we took like a, I don't know, like a 3 by 2 matrix and I multiplied it by a 2 by 1 matrix, I guess that should be defined. Okay. All right. Well, big deal. So what? So we've learned when it's defined, but you haven't even told me what the product should be. Well, let me tell you that next. So if we multiply a times b, and I'm going to write that out. So I'm going to say n by n times, now remember, these two middle numbers have to be equal. So these middle numbers have to be equal, so I'm just going to write n times, I don't know, maybe r here. Sorry, maybe I'll call it s. So it's consistent with the other one. Then the result will be an m by s matrix. Okay? And so the product size of the product AB is given by the outside numbers. Okay? So what do I mean by that? Well, how do we decide whether the matrix product was defined? We said that the inside numbers had to be equal. And what was what I tell you the answer? Well, I said the answer was going to be the outside numbers. And so m and s are the two outside numbers that we have. Right? And so what you're checking to make sure the product is defined is you're checking that the inside numbers are the same. And then if they are, then you're going to be able to multiply those matrices. And then the product will be given by the outside numbers. Okay? So I'll tell you what, let's just do an explicit example of one you know how to do. So let's try this one. So let's try a matrix like 1, 2, 3, 4, 5, 6 times, I don't know, 1, 7, let's make smaller numbers, 1, 0, 2. Okay? This is a product that we've done before. Right? And remember, I did this thing where I kept emphasizing that we do the first number times the first column, we do the second number times the second column, and then the third column times the third entry times the last column, and we add them up, right? And if we do that, what do we get in this case? Well, in this case, there's also a shorter way to do it, is to kind of go across the first row and go down. If we do that, we're going to get 11. And then in the second row, when we do that, we're going to get 2 plus 12, which is 14. So at the end, we get the matrix 11 and 14. Well, what did we just do? We just multiplied two matrices. And what were their sizes? So here, think of this as our matrix A, this is our matrix B, and this is the matrix, their product, A times B. What were the sizes? Well, A was 2 by 3. B was 3 by 1. And what was the product? Well, the product was 2 by 1. So this is showing us that this product was defined because the middle numbers were the same. You can imagine they kind of get scrunched together. You can kind of imagine this whole thing just kind of gets blah, 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 blah together. And at the end of the day, our product wound up being 2 by 1. Okay? So I know this is weird if you've never seen this before, but I promise you you'll get used to it. And so the first thing I want us to know about multiplying matrices is just how to tell whether or not they're defined and what the answer will be. Right? So let's just do some more examples. So let's see. Suppose I have a 4 by 3 matrix, A, and I multiply that by a 3 by 4 matrix. Okay. So then AB will be a 4 by 4 matrix. Okay. Again, it's defined because we can match up the insides, and the outsides are going to give us that answer. Right? Now, what happens if we do it in the opposite order? All right, let's take those same two matrices, B and A, but let's do them in the opposite order. If we do them in the opposite order, B was a 3 by 4 matrix, and A was a 4 by 3 matrix. Let's check if it's defined. It's defined because these middle numbers are equal. And are the outer numbers? Well, the outer numbers are going to tell us about the answer. So this says that B times A is a, oh my goodness, 3 by 3 matrix. Okay. So we're going to do an example of something like this in a second. And it's a little jarring because look at what I just wrote down. A times B is a 4 by 4 matrix. B times A is a 3 by 3 matrix. That is weird. What that shows us is that A times B and B times A might be completely different. Right? And this is maybe the first time you've seen an operation like multiplication where the order matters. Right? And you've seen lots of examples of this in your real life, right? Like we all know that like it makes a difference whether you, what's a good example, right? Like if you're gonna brush your teeth and then drink some orange juice, right? It kind of matters the order that you do that. If you've all kind of done that in the wrong order, you get a big surprise. If we, let's say we have two operations, like let's see, say we have A was something like add $5, and then B was double your money. Right? So imagine I let you push both of these buttons, but you got to decide what order, right? And so let's say you start with $50. If first you hit the A button, you'd go to 55, and then you hit the B button, you would go to $110. Okay? And now let's do the same situation, but instead let's switch the order. So first you hit B, that'll take you to 100, and then let's have you add 5. That's only going to get you to 105. And so even though they're the same operations, the order that we perform them in really makes a difference. I would choose the first option because I'd wind up with more money at the end. And so a lot of life actually order does matter. Right? You can, and matrices are no exception to that. Okay? All right, so enough talking. Now let me show you how the matrix operation works. And so I'm going to go back to that example that we did earlier. I'm going to make up a matrix. Let's try to do a 4 by 2 matrix. Times a 2 by 2 matrix. Okay? And I want to start with a 2 by 1 matrix. Right? And I just want to see what's going to change. So imagine we had this matrix here. Let's make the entries pretty simple. Let's make them like mostly zeros. I don't know what I'm doing. I meant to put these down here. Okay, good. So here is our 4 by 2 matrix. Right, 4 rows, 2 columns. And what we could do, we know absolutely how to multiply by a 2 by 1 matrix. Right? If I put like an x1 and an x2 there, you would totally know what to do. You would take the x1 times the first column, the x2 times the second column, and you would add them up. Right? Or you would do that trick from one of my earlier videos where you would kind of go like this to get the first output entry, then maybe you'd go like this to get the second output entry, then maybe you'd go like this to get the third output entry, and then maybe you would go like this to get the last output entry. Okay? And so that would work perfectly. And if we did that, we would wind up with a 4 by 1 matrix. Right? 4 by 1. And look, there it is. It's 4 by 1. Now, what if we change this, though? So I said I didn't want to do 2 by 1. I actually wanted to do a 2 by 2. So if instead I want to do a 2 by 2 matrix, then what should the outputs be? Well, that rule says it's supposed to be a 4 by 2 matrix. And so I need to have 2 columns. Goodness, I don't know what's going to go in these entries. Let me just kind of clean all this up. But our matrix here in the middle is now a 2 by 2 matrix. And so it's going to have some entries. So I don't know what those entries are. Maybe they're 1, 0, 2, 3. Something like that. And we've got all of these entries over here to fill out. And I want to tell you that how we're going to get those entries is exactly what we did before. It's just now we have 2 columns to work with. So if we use this column here, this is the first column, then we can do that property that I did before, where I go like this and I go like that, and I kind of multiply those together and add. And what would I get? I would get 1 times 1 plus 1 times 2, I would get 2. I'm just going to write that down here. In fact, I'm going to do that process throughout all of these. If I do that, I'm going to get 2. If I do this, I'm going to get 2. If I do this, I'm going to get, oh, that's kind of boring. I keep getting 2. Right? It's just a coincidence. Right? And now, I'm going to do the same thing over here. Right? So now if I want, that was the first column of my answer. If I want the second column, then what I'm going to do is I'm going to do exactly the same process, but instead of using the first column of this matrix, I'm going to use the second one. So if I do that, I'm going to get 3. If I multiply this one and this one, I'm going to get 3. If I multiply this one and this one, I'm actually going to get 0. And if I multiply this one and this one, I'm going to get 3. Okay. And so I'm going to do a few more examples of this so we can kind of see the pattern. But basically what we're doing is we're just multiplying rows and columns to get our entries. So I think there's a picture. Let me see if it's up or down. I can't remember. I think it's up. Yeah. Right. And so here we're trying to multiply. This is an example in the book. By the way, you should read this section of the book because they do a lot more examples than we're going to be able to do. And we're trying to multiply A times B. And so we've got this matrix A and this matrix B. And again, let's check that size. Right? A is 4 by 3. B is 3 by 2. And so the answer, the output, the product of those matrices is going to be 4 by 2. And we got to check that those inside numbers match. And they do. Okay? And so now our answer is, the answer should be a 4 by 2 matrix. And oh, there it is. They've got that answer filled out. And so if we want to find the entries, what we do, so let's look at, they found this entry 5. So how did they find that entry 5? Well, they notice it's in the first column of the output. And so they looked at the first column of this matrix. And they notice it's in the second row of the output. And so they looked in the second row of the first matrix. Right? Now you may, as you're doing this, you may forget which one is which. But one way that you can kind of check is that, suppose I were trying to, well, maybe I'll say that in a second. We'll compute some more entries in a second. And so then what do? Well, we do exactly this highlighty thing. So I want to find the entry in the second row in the first column of my output matrix. I'm going to look at these numbers and I'm going to combine them. And when I do that, I multiply. I do -1 times 4, 3 times 7, -4 times 3, and I add them together and I get 5. And that's what's going there. And similarly, if I want to find the output over in the second column, well, I'm just going to pick this up and move it over one. And I'm going to go like this and like this. And if I do that multiplication, well, again, I do -1 times -6, 3 times 1, -4 times 2, and I add those things together, I'm going to get 1. So that's how I got that number down there. Right? And so now what we're going to do is we'll just do one more entry down here. So maybe I'll do the bottom one. Right? So how would I get that bottom entry? In fact, maybe we'll do this one over on the right. Right? So it's in the 4th row. And if I'm confused about which matrix I take the 4th row of, well, the second matrix doesn't even have a 4th row. So it's always the row of the first matrix. And then the columns come from the second matrix. Right? And so we're going to do that. We're going to do that. And oh my gosh, let's do that. Let's work it out. So to find that entry, I'm going to do -3 times -6. That's 18 plus 0 times 1 plus another 18. So 18 plus 18, this entry will be 36. Okay. And so if I want to calculate how to multiply matrices, I just have to do this process to figure out what all of those entries are. Now you're right, this can take some time. This product had 8 entries, so we'd have to do this procedure like 8 times. We'll get some practice doing this on the homework. Computers can be really helpful for doing this sort of thing. And so I want to end just with this last example here. And this may be a good time to maybe pause the video and just check some of these entries yourself. And so we have 2 matrices. They're both 2 by 2. So they're 2 by 2 and 2 by 2. And so the product's defined because the inside numbers match. And the output should be 2 by 2 because the number's on the outside. And if that was A times B, well, if we want to do B times A, we'd just flip the order. So we would put B over here, and we'd still see that matchup kind of happens. So both matrix products are defined. We can do that multiplication, but the way that the numbers are going to combine is going to be really strange, right? And so let's just try it. So go ahead and pause the video and try to work out these 2 multiplications and double check that you get these numbers. I'm just going to check one of the numbers in each case. I'm going to check the bottom. I'll check the bottom left corner down here, and I'll check the upper right corner in the second one. Right? And so if I want to check that -2, what I would do is I would take this row and that column, and I would multiply and add. So 3 times 2 is 6, minus 2 times 4 is, so 6 minus 8, -2. Right? And then when I go down in the second example, maybe I should change colors. I'm going to do top row, second column, and that's going to give me 2 times 1 plus 0 is 2. Okay? And so if we check all these things, we get these matrices on the right, and we see that AB and BA are not the same. So just like that button that added $5 and that other button that doubled our money, those don't commute. Right? They're not the same. And so we've got these warnings down here. It says, in general, AB is not the same as BA. That's really, really, really important. Another warning is that AB could be the same as A times C. It might not be true that B equals C. So we're gonna encounter that in the class. And even it may be true that A times B is a zero matrix, but neither A nor B might be the zero matrix. Let me just show you that now, just so you can kind of see it. And I'll show you in a kind of an easy way. Let's take a 1 by 3 matrix, and let's multiply by a 3 by 2 matrix. Okay? And of course, that output should be a 1 by 2 matrix. Right? So 1 by 3 times 3 by 2 should be 1 by 2. And I'm just going to fill in some numbers. I'm going to do 1, 1, 1. And here I'm going to do 1, negative 1, 0, and then 1, 0, negative 1. Neither, in fact, I'm not going to put zeros anywhere in the matrix, just so this is really convincing. Right? I've got two matrices here, and neither one of these matrices is 0. But let's multiply them together. This is going to be pretty easy, because we only have 2 entries to work with. So that first entry is going to be this row times that column. 1 minus 2 plus 1, that's 0. Okay, 0. And now let's do the other entry. Right, that other entry now is going to be the first, that row times that column. Again, that's going to be 0. And so what did we see? We have the product of 2 matrices. Neither one of those is 0, but the product is 0. And so weird things can happen with matrices, and we're gonna discover more of these things as we go through the course. So thanks for watching these videos. Thanks for coming to class on a Saturday. And in Monday we will learn more about matrix multiplication and